The parabola in the solvent has the equation h equals negative 16t squared plus 32t plus 4. Unlike the quadratic functions you saw in previous lessons, this function has a linear term, 32t. In the quadratic function y equals ax squared plus bx plus c, the value of b affects the position of the axis of symmetry. Note this graph. Here we have graphed the equation y equals 2x squared, forming the parabola shown here in orange. Note also, 2x squared can be thought of as 2x squared plus 0x. So the ratio b to a, in this case, is 0 to 2, and that's 0. So our axis of symmetry is the line x equals 0, also known as the y-axis. Consider this equation and the graph of y equals 2x squared plus 2x. The ratio b to a is 2 over 2, or 1. In this case, the axis of symmetry is the line x equals negative 1/2. In this graph and equation, y equals 2x squared plus 4x. The ratio b to a is 4 to 2, or 2. And in this case, our axis of symmetry is the line x equals negative 1, which note we could also think of as x equals negative 2 over 2. And this graph and equation, y equals 2x squared plus 6x. The ratio b to a is 6 to 2, or 3. And our axis of symmetry is the line x equals negative 3 over 2. As the pattern suggests, the equation of the axis of symmetry is x equals negative 1/2 times b over a, or x equals negative b over 2a. Take note, key concept, the graph of a quadratic function. The graph of y equals ax squared plus bx plus c, where a does not equal 0, has the line x equals negative b over 2a as its axis of symmetry. The x-coordinate of the vertex is negative b over 2a. When you substitute x equals 0 into the equation y equals ax squared plus bx plus c, you get y equals c. So the y-intercept of a function is c. You can use the axis of symmetry and the y-intercept to help you graph a quadratic function. Problem 1. Graphing y equals ax squared plus bx plus c. What is the graph of the function y equals x squared minus 6x plus 4? Step 1. Find the axis of symmetry and the coordinates of the vertex. Well, as we know, the equation of the axis of symmetry is x equals negative b over 2a. And in this case, that's negative of negative 6 over 2 times 1. And that's 3. The axis of symmetry is the line x equals 3. So the x-coordinate of the vertex is 3. Substituting 3 into the equation, we find y equals 3 squared minus 6 times 3 plus 4, or negative 5. So we can now state the vertex is the point 3, negative 5. Step 2, find 2 other points on the graph. First we'll find the y-intercept. When x equals 0, y equals 4. So one point, the y-intercept, is 0, 4. We'll then find another point by choosing a value for x on the same side of the vertex as the y-intercept. In this case, we'll let x equal 1. When x is 1, we find that y equals negative 1. So another point is 1, negative 1. Step 3, we'll graph the vertex and the points found in step 2, those were 0, 4, and 1, negative 1, and then we'll reflect the points from step 2 across the axis of symmetry to get 2 more points on the graph. Then we'll connect the points with a smooth curve, forming a parabola. Your turn. Part A. What is the graph of the function y equals negative x squared plus 4x minus 2? And part B, a reasoning item. In step 2 of problem 1, why do you think it was useful to use the y-intercept as one point on the graph?